really need to take a deep look at those open source applications that you're either embedding in your code or that you're actually using in your environment. This is back to that, I had actually never seen this picture. I might be giving away my age. This was a 1996 study, Capers-Jones. And this is just an aside because the focus of the talk really isn't on this. But I actually like this because most of your defects occur during your coding phase. However, most of them are being detected towards the tail end. Right? So if you start embedding a little analysis, a little source code analysis a little earlier on, you're going to start detecting those problems a little bit earlier on. And I would say that you could probably say, move this. They're looking for bugs, functional bugs. But I would say this would probably map very well to security as well. Security defects, are introduced early on, and the earlier you detect them, the more likely it is to cost less to fix them. So underneath all those applications that you have out there is software. It's the stuff that you write or that you buy or that you steal from the internet. Open source, I guess you're not stealing it. So you have to think of it, it's kind of like a set of roads where you have your designated path coming in and then coming all the way down to your business critical asset. Now code doesn't run sequentially from line 1 to 100. So what actually happens is that you have all these paths through the code. Whether they're intended paths or unintended paths, you still have all of these different roads that are going to end up at that business critical asset. Not only that, but you have all these different methods of getting there or potentially accessing it, right? Are you putting that data on your laptop unencrypted? Is your admin able to view unencrypted data in the database that's protected on the server? These are different ways that you might be able to access that critical information. So with source code analysis, and I'm going to take a step back here and talk about what I mean by source code analysis. There's really kind of two main camps. You have the whole manual review people, and then you have the whole automated static source code analysis is the answer people. Well, I kind of fall in between. I think that source code analysis, at least for this talk, is tool-assisted manual review. Because source code analysis by itself is going to solve a lot of problems for you, but it's not going to solve all of them. And manual review by itself, there's too many paths to your code. There's too much. It requires too much headspace to be able to remember all those paths through your code and be able to follow them all through. So you kind of have to combine both. And with source code analysis, you can actually identify all those paths. You can look at the interesting paths. You can find the paths that actually have credit card data or privacy information on them. You can find the paths that that are pointing right to your SQL injection. It will give you the actual line of code. So let's take an example, protecting credit card data. So you have to ask yourself, am I taking the right level of responsibility to protect my clients and customers? Do I have the proper secure coding best practices throughout the SDLC? Do I have security requirements for my outsourcers? Do I have acceptance criteria for any client or customer data containing application? Right? These types of questions are not your typical OWASP top 10 types of application security vulnerability questions. So why is it important to listen to your software? Well, your software is kind of like the gateway to your data. Right? Look at how complicated a simple credit card transaction is. It comes into your application. It's going to go off to the transaction authorization. It could potentially be hanging out in memory for a long time. It might leak out to the file system through maybe a debug statement that wasn't caught, or perhaps they're actually storing it out on the file system. Who knows? It might be going into the database. I mean, you can certainly store some privacy information in the database. Are you protecting it properly? Are you sending it to partners or remote systems? Right? I mean, there's a lot of stuff going on, with it inside of your application for your data, and you need to understand what all those paths are to truly understand, where things can go wrong and how they can actually impact your security. Any questions so far? I like interaction. It's not very interactive. I guess it's not a very interactive talk. Okay, so PCI. Everyone's heard of PCI, right? The payment card industry. I'm quite sure everyone's probably familiar with it. PCI, it's a fantastic example of generic good best practices. I really like PCI. I mean, look at this. What they've done in PCI is they've allowed, or they've provided a way to characterize and categorize your data. By looking at this simple little chart here, I can see exactly what I need to do as a developer, or I can see exactly, what I'm supposed to do as an enterprise with the PCI data. I mean, it's pretty clear. Yeah, I can store the PAN or the account number, but yeah, I got to encrypt it. Okay. Okay. Well, I can store this other information, but if I store the PAN along with it, then I have to encrypt it. Am I allowed to store any of that other data? No. Right? All of a sudden, the whole world becomes crystal clear, when you're given a little chart like this. And then PCI even goes a little bit further, and they extend that data characterization and categorization. And they start adding, a little bit of functional requirements. They start talking about authentication, access control, logging, communication, secure coding guidelines, right? And once again, this is presented in a pretty digestible format. Normally, you don't get data like this in an easy to consume, easy to understand, easy to validate against format. Speaking of digestible formats, anyone ever seen an access control matrix? Where you have all of your functionality down one side and all of your user roles across the top or across the bottom, right? And then, for every single role, you put a little X, for the things that you're allowed to access. Anyone ever seen one of those? Right? Once again, it's a fantastic way of being able to represent, very, very complex logic. Okay, so let's pop back up to the 50,000-foot view. So applications don't need the same level of security, right? They don't, it would be nice if they all had the same level of security, but they all don't need the same level of security. You actually have to have more security on your, internet-facing money transaction application than you do on your intranet-facing, HR benefits application. Not what you get as benefits, but what describes the benefits. So I like to look at this little magic 4-quadrant chart here, and for all of your applications in your organization, you really need to perform some sort of a triage on them. You really need to decide, hey, what is the risk level of each one of these applications? What is my exposure versus my impact? And then if I have high impact, high exposure, I have high risk. I need to make sure there is more security in that particular application. And conversely, you have the other down left bottom corner that is your low risk application. And to put this into perspective, I used to use the Jeff Williams example of an asteroid hitting Earth. If you think about an asteroid hitting Earth, the impact of an asteroid hitting Earth is huge, but the likelihood is really small. And as I was trying to convince my 12 and 14-year-olds that this was actually a very interesting presentation, as they were diligently sitting and listening to me, give it to them, I came up with a better example that kind of hit home a little bit more. Actually, I felt really bad because my 14-year-old, when I was done, he told me that I should give the presentation just before bedtime. that really makes you feel bad. So anyhow, I tried to come up with a more realistic example of this because it's kind of, everyone really understands it. But what really drove it home was I came up with the example of, let's say that you're sitting in a hallway and somebody has a gun, 14-year-olds' guns, and somebody has a gun and they're pointing it right at your head. And when they pull the trigger, you have a 1 in a million chance of that bullet actually hitting you. Okay? So what's the overall risk of that? The likelihood of that 1 in a million chance of it hitting you is really, really small. But the impact is huge. Would you be willing to take that risk? Right? Personally,